Dear students, in this video lecture we are going to see about the temperature effect on the arch. So temperature effect means whether there is a geometry reduction or geometric change, or there is a reaction force change occurs in the arches. So we have two classification: three hinged arch and two hinged arch. Okay, so three hinged arch, we have crown point at the top and simply supported at two springing levels A and B, and we have the hinge point at C. If there is a temperature change, if there is a temperature change in this arch profile, so the support is a simply support, will not allow any displacement in this direction. So the hinge point will allow some uh, rise due to the temperature effect. So I can draw the revised diagram. So the C will become C dash after the temperature change. So we are going to calculate C dash in case of three hinged arch, because the hinge point will allow, it will act as an expansion joint. So it will allow some rise in the height of the arch. Okay. In two hinged arch, so we are having only the supports, there is no crown point. So the vertical reaction will counteract the vertical loading. The horizontal reaction will take over some additional value due to the temperature rise. So the H will change. Well, initially the H will be H0, and due to the temperature change we will have additional H1 um, depending upon the magnitude. So the H will turn to H0 plus H1 in the case of two hinged arch. In three hinged arch, the temperature will give some rise of the crown point. So we are going to calculate C dash in three hinged arch profile. So again I am drawing the three hinged arch profile, the support levels, the crown point C, and the revised, the new point C dash. So I'm going to draw the straight line for C and C dash. This is A and B. Similarly from B to C and B to C dash. So we are having theta here. The depth here is YC and half of the length is L by 2. So these are the parameter representation for our calculation. So consider a right angle perpendicular line for this B to C dash. So the B to C is measured here, and we have some additional expansion due to the temperature rise. So what is the expansion here? Due to the temperature effect T with the thermal expansion coefficient alpha, we will have the strain formula as alpha into T, and the change in length will be L alpha T. You might have studied in your previous semester solid mechanics. Okay. If it is in the case of B to C, if you consider the length is BC, means the length of expansion is BC alpha T. So this length is BC alpha T. Okay. BC alpha T. Now you consider, so we have to find out C to C dash, the right angle triangle. Here it is BC alpha T and theta. This is theta means what is sine theta? Sine theta equal to opposite BC alpha T by hypotenuse C dash. We require C dash equal to BC alpha T by sine theta. So in this formula, we are going to replace BC and sine theta with only one parameter. So for that, I am considering overall triangle of this three hinged arch. This is hinge point A and B. This is YC, the depth is YC. Here L by 2, the horizontal theta here, okay. B to C. Now, what is cos theta? Cos theta equal to L by 2 by BC, where BC equal to L by 2 by cos theta. Others we can write as L by 2 secant theta. From the left side portion A to C, A to C, if it is theta, YC and L by 2, here it is AC, we can write it is for cos theta equal to L by 2 by AC, okay. 1 by cos theta equal to secant theta equal to AC by L by 2. This is one part we are going to replace with this term. Another part, sin theta equal to, because we have sin theta here, sin theta equal to YC by AC. So we are going to replace secant theta in terms of AC and sin theta in terms of AC. So BC equal to L by 2 secant theta. So that here I can replace BC to L by 2 secant theta alpha T by sin theta. In the next page I am going to rewrite this. C dash equal to L by 2 secant theta alpha T by sin theta. From this previous page, secant theta equal to AC by L by 2, sin theta equal to YC by AC. Secant theta equal to AC by L by 2. Sin theta equal to YC by AC. So substitute here L by 2 into AC by L by 2 into alpha T by YC by AC. So we can remove this L by 2 term, and AC square alpha T by YC is CC dash. From this triangle A to C and L by 2 and YC, AC square equal to L by 2 square plus YC square. So we can replace CC dash with the available geometric parameter L by 2 whole square plus YC square into alpha T by YC. You can keep this equation itself, or you can simplify further. So this is all about three hinged arch. So next one, two hinged arch. Two hinged arch problem. Already we knew that there is only supports, there is no crown point. So H will counteract the temperature stress as well as the basic horizontal thrust. So H is H0 plus H1. H0 is the initial horizontal thrust. Already we have derived this formula. H1 is equal to, we will be having further, okay, no need here, okay, H0 plus H1. So we can derive from the basics. That is the strain energy equal to in terms of bending moment m square ds by 2EI, where m equal to mu x minus h into y. While considering a section x from this support, if you consider the bending moment here, mu x is the bending moment due to the vertical loads minus hy mu mu x minus hy is the horizontal thrust equation. Okay, ds, it is a surface length. Further, we will be reducing as dx secant theta. How we can reduce? Cos theta means dx by ds. So ds equal to dx by cos theta. So dx into secant theta. So you keep in mind in this relation, we further are going to replace ds in terms of dx. Okay. So this is what about m. Okay, u equal to mu x minus hy the whole square ds by 2ei. We know that from the Castigliano's second theorem, the rate of change of strain energy with respect to applied load is equal to 0 in normal condition. But due to the temperature change, this will not be 0. This is actually the displacement. What is the displacement due to the temperature change? Alpha T is the strain and L alpha T is the displacement. So we can refer to L alpha T. So we should equate to L alpha T in this. And also we can replace H is equal to H0 plus H1 due to the additional horizontal thrust. So dou by dou H of, this is actually integration equation. This integration of m square ds by 2e. Dou by dou h of mu x minus h0 plus h1 whole square ds by 2ei equal to L alpha t. So if you differentiate with respect to h means 2 times of mu x minus h0 plus h1 um, into y I have missed here, into y, the whole square, into y the whole square. So 2 times of mu x minus h0 plus h1 into y. If you differentiate minus h into y, h0 plus h1 will be 1, so minus y ds by 2 times of ei. So 2 cancel. So integration of, so this will be equal to L alpha t. Further I am reducing to mu x plus h0 plus h1 into y square ds by ei equal to L alpha t. So I am going to split the portion h0 into y square and h1 into y square. So on the next page, mu x into ds by ei plus h0 plus h1 into y square ds by ei equal to L alpha t. And mu x ds by ei actually in this previous steps, if you are multiplying 2 times of mu x minus h0 plus h1y, y is common to both expressions, so we have to multiply minus y with this mu x. So minus mu x into y will be the term. So I'm considering yes minus mu x into y plus h0 plus h1 y square ds. So into y ds divided by ei plus h0 y square ds by ei plus h1 y square ds by ei equal to L alpha t. So if you consider this two term, this is basic definition for the horizontal thrust of two hinged arch, and we also consider dou u by dou h equal to 0 in that case. By this only we are calculating h equal to integration of mu ds by a divided by y square d. If you consider this equation, mu x y ds by ei plus h0 y square ds by ei equal to 0. h0 equal to integration of, so this you have the integration format. Okay. Integration of mu y ds by ei divided by integration of y square ds by ei. So this is the actual formula for calculating the horizontal thrust basically into hinged arches, and it is zero because of zero displacement at the support level without considering the temperature stress. So we can equate this two term equal to 0 plus h1 y square ds by ei equal to L alpha t. So h1 equal to L alpha t by uh, integration of y square ds by ei, y square ds by ei. Here we can consider ds equal to dx secant theta and I equal to I naught secant theta for our comfort. L alpha t by y square dx secant theta by E I naught secant theta. So secant theta will be cancelled. So H1, the additional horizontal thrust due to the temperature change equal to y square dx by E I naught. So this is the formula for the additional horizontal thrust due to temperature change. So with this formula we can do some problem to find out the additional horizontal thrust, and in three hinged arch we can find the expansion of the rise of crown point from C to C dash.